These problems use a formula you are probably familiar with. Distance equals rate times time. Here's an example. Keith took a trip of 300 miles. He averaged 50 miles per hour for the first 100 miles, 70 for the next 140 miles, and 60 for the last 60 miles. What was his average speed for the trip? We will use the formula to determine the rate, which is the average speed. We already know the distance is 300, so we have to determine the total time. The first 100 miles took 2 hours because he averaged 50 miles per hour. The second 140 miles also took 2 hours because he averaged 70. And the last 60 miles took 1 hour because he averaged 60. Therefore, the entire trip took 5 hours. So we have distance equals rate times time, or 300 equals rate times 5, 300 divided by 5 equals 60, and that equals the rate. That is, the average speed was 60 miles per hour. At the simplest level, such as in this example, these problems deal with the relationship between time, distance, and speed using the formula. But this idea can be generalized to apply to any proportional relationship that's linear. This is illustrated in our next example. Meredith sold 14 insurance policies during January, February, and March. If she continues at this rate, during which month will she sell her 50th policy for the year? In the first 3 months of the year, Meredith's rate of selling policies has been 14/3 policies per month. To apply the formula, we need to think of the distance as 50, and we need to find the month during which she will sell her 50th. Plugging into the formula in this situation, we get distance equals rate times time, so 50 equals 14/3 times time. And solving for time, we get 150 over 14 months equal to time. So 10 and 10/14 months equals time. In other words, it will take her 10 and 10/14 months to sell 50 policies. That is, she will sell her 50th policy in the 11th month, November.